Hello! PLA is a rigid and easy to get clean prints with, so it's no wonder it's the most common 3D printing material. But it does have its significant downsides. For example, it's brittle and it doesn't handle high temperatures. So it's also no wonder why manufacturers have tried to improve on the basic PLA formula. The filaments we look into and compare in this video are Sunlu PLA Plus, improved strength, stiffness, toughness, durability, heat resistance, ease of use, eco-friendliness, gives more smooth and delicate surface. And Elegoo PLA Pro, low warping and shrinking tendencies, better temperature resistance, dimensional accuracy. And Esun PLA-ST, tougher than PETG, high impact resistance, high elongation at break, high bonding strength, high accuracy, resistant to air oxidation. And Spectrum PETG-HT100, excellent durability and dimension stability, increased temperature resistance, high stiffness. And as a reference, we have regular Sunlu PETG, Spectrum PLA Silk, and partially also Fiberlogy Nylon PA12. I also want to mention that I'm not affiliated with any of these companies. I have bought all these filaments myself with my own money. I only make these videos as a hobby to inform people, not to generate income of any kind, not even from YouTube. Now, my testing methods aren't fully scientific, as it wouldn't have been worth the effort for me to follow measurement standards or such. And in my opinion, if the differences are small enough to require special measurement devices, they are too small to really affect the purchase decision. In that case, the available colors, shipping times, even brand loyalty, and especially the price matter a lot more. I think I'm still able to make a reasonable comparison, but if you'd want to see standardized hard data to back up all the findings, this video might not be for you. So, let's start by showing you how not to open the Spectrum PETG-HT100. It didn't look like it at first, but there is a closing strip after all, which I stupidly cut through right here. First, the printing conditions. I'm printing on a GD+4 on a 0.4mm nozzle and 0.2mm layer height. The settings that differ between the filaments are outlined here. I have already used several rolls of Sunlu PLA Plus in various colors, and despite their recommendations, I always print at 230 degrees Celsius, as it gives me the preferred balance of shine, overhangs and speed. Still, for this test, I mostly used the highest recommended temperature on the PLAs. PETGs are more picky though, so they required a bit more tweaking. Then the tests. I've got an overhang test, rigidity test, layer adhesion test, a hardness test, and finally a temperature test. We'll start with assessing the overhangs. This is only one printing situation, of course, but the model is pretty demanding as it has 100% overhangs. The model is 30mm wide and 16mm tall. First is the Elegoo. This overhang gets very steep, and at the end there are a few layers where the overhang is 100%. So it is a bit tough to print. But here we can see that the print quality is perfect. The seam is pretty visible, but I'm sure that that could be tuned out somewhat. I have a scarf seam on the straighter section, but that too would benefit from a little tune-up. But yeah, overall, perfect. Then the Sunlu PLA Plus. Likewise, perfect quality all around. Then is the Esun EPLA, and here's what happened. It completely lost the two full overhangs. They didn't grab at all. So this was with the highest recommended temperature 230. So then I lowered it to 220, which was well within the range, and it became much better. There's very tiny waviness on one of the edges. I don't know if you can even see that, but that makes it maybe 4.9 out of 5, so it's near perfect. Then we go to the PETG. So here's the HT100. So and so, not all that good. At the end of the loop, it's actually pretty good. Oh yeah, it has dropped a bit. It's not smooth like it should be. So this is maybe 3 out of 5 at most. But this too could be improved surely with some settings, but I don't know if it can ever print as smooth as these PLAs. Then we go to the regular PETG from Sunlu, and this is even worse. Yeah, the cooling hasn't been enough for this to work. And these were the PETG settings that I have been using that have been very good for me. But overhangs are pretty tough at this level. So overall, the PETGs require a lot more tuning and trying out different settings. But PLA, at best, it just works really great, or it can be easily made great with just a temperature change. Then let's look at the reference PLA silk. The overhang is perfect. The seam maybe not as perfect as it could be. Tiny scrub there, but small enough that I'm sure that with a little settings adjustment, it'll be just as good as this. So very good. I'd say 9 out of 10. Then the vertical bars. The bottom part of this was printed with the other parts, so this had a good time to cool. But after that, it was printing only this part. So there is a significant change at that point. But the top part still looks very good. And overall the seam is hidden perfectly. This was printed with a scarf joint, but the bulge here is pretty prominent. Then the PLA Plus, same thing. There is a bulge, but it's not maybe quite as big. And also very smooth and even. PLA Pro. Actually the scarf joint didn't quite work out as well. It's not perfectly round. The bulge is quite visible, but yeah, not quite as good as the others, but pretty okay. Then the HT100, and actually I had to print this alone because it just wouldn't hold on to the bed with a 3mm brim. So I had to put the brim closer and widen it up. So that's why this doesn't have the bulge. And overall, you can see from the shine that it's not perfectly round, but it's pretty good. Then the regular PETG, and here you can see the bulge. Oh my god. It's really strange because the bottom part is just as good as the other, and the top part as well, just as good as the other. But it's this middle section that's tough. And this is the section where this is ending, so this takes a lot of layer time. So one would think that this has a good ample time to cool, but no, that's how it presents itself. Yeah, again, PETG, not the best. Then we take the vertically printed pole. Again, there's a bulge, only on one side though, the other side is clean. Then we'll try to measure the horizontal round bar that I printed. The first layers, they of course are really difficult to get round when printing horizontally. So there are usually clear deviations in the diameter. Yeah, this drops from 4 to maybe 3.7. My digital caliper is broken, so I haven't gotten a new one yet, so I have to trust this. The PLA Plus goes from 4 down to, oh actually it goes up, 4.1, but it doesn't go below 3.9, so it's a bit better. eSun EPLA, 4.1, 3.7. So this has the most unevenness out of the PLAs. Then we go to PETG-HT100 from 4 to 3.7. Yeah, and you can feel it's not very round. This feels more round. This is the basic PETG. 3.8. Yeah, it's surprisingly good. There's actually a single sharp edge, while the PLAs have more rounded. Even though the diameter changes, it's more rounded overall. When you roll it in your fingers, you don't notice any change in the diameter. Yeah, this maybe looks even the smoothest. Hard to say because it's a different color. Then rigidity. This bar is sized 2 by 8 by 80 millimeters. Let's assess them first by hand. If I have to put them in order, that's quite stiff. This is very soft. So the order is: the softest is the HT100, second is the eSun PLA-ST, then is the regular PETG, then the Sunlu PLA Plus, and then the Elegoo PLA Pro. That's the stiffest.
The differences between the first three are quite small, but then it starts to drop out. This is really soft. Then we have the silk PLA. On hand, this feels very rigid, at least as rigid as the Elegoo PLA Pro. Feels hard.
I also tested the parts with a 1 kilogram weight when the object is placed between supports that are 60 millimeters apart.
Okay, this is the Elegoo. And for reference, without bending, it is 32.6. So I'll put it on the same way that it was printed. Then I have my weight. Then I'll measure the distance, and it's 29.3 millimeters. So this is the Sunlu PLA Plus, 1 kilogram there, and measuring 29 sharp. Then we go to number 3, which was eSun PLA-ST, 28.2. Then the most expensive of the bunch, the Spectrum PETG-HT100. Oh my god, 22.1. This is really bendy stuff. Then the reference, which is cheapest PETG that Sunlu offers. Oh my god, 28.2. Reference silk PLA. We measure the baseline 32.8. Then we put a 1 kilo weight. Look at that, 29.7. That might be the winner.
Then we start breaking things. This is a vertically printed 30mm tall and 4mm thick cylinder. Then we'll try to snap them in half. So this is the Elegoo PLA Pro. Yeah, can be done, but it was pretty difficult. Then the PLA Plus. Significantly easier. Then the PLA-ST. About similar to the PLA Pro, maybe ever so slightly easier. Then the PETG-HT100. Easy. About as easy as the PLA Plus. And the regular PETG. Yeah, easy as well. And let's try to snap this silk PLA. I'd say medium. So these two had much better layer adhesion. PLA Pro by Elegoo and PLA-ST by eSun. Then we assessed the hardness by squeezing a horizontally printed 30 by 4mm cylinder, both vertically and horizontally. So now we are squeezing from top to bottom. Oh yeah, this squashes like a bug. And then from left to right in the printing orientation. Same thing, squashes like a bug. So the first measures 1.9, second is exactly 2mm. Then the PLA Plus, top to bottom. This feels tougher. And then horizontally. Yeah, definitely feels tougher. First one measures 2.1. The second one made it crack completely, 2.2. But yeah, this first one held its shape despite being squashed, but the PLA Plus, it cracked open along the layer lines. Then the PLA Pro, top to bottom. Yeah, this feels softer again. And left to right. Yeah, this is soft. 1.9, 1.9. But it didn't take much effort. Then we go to PETG-HT100. Top to bottom. This is tougher. Definitely feels tougher. 2.2. 2.3. Wow, that was a surprise. It did well. And the regular PETG, top to bottom, I could hear it crack and it squeezed real easily. And that was from top to bottom. Same thing left to right.
This is 1.7 on a good day, 1.8. Then we take the silk PLA. Oh my god, this is hard. This really is hard. And then horizontally from side to side. There we go. It exploded all the way through. Well, that's not a pass. We'll measure the vertically squeezed parts. And it is 2.2. There we go. Big differences in the toughness. And now we bake them. The stake temperature meter seems broken, so we can only assess the time it takes for each to melt, as I don't think we can rely on the oven's own temperature readings. The supports are again 60 millimeters apart, and there's a 4.6 gram nut weighing down on top of the model. And here we have the timer. We'll of course speed up the boring parts directly to the action sequences. The relative announced heat deflection temperatures are reflected very well, and looks like the higher melt index value of the PLA Pro shows here as the longer time from when it starts to melt to when it finally falls off the rails. As expected, the HT100 handles much more heat than the rest. Then we have the reference filaments compared to the HT100. PLA Silk is on par with the PLA Plus and PLA-ST. HT100 gets similar times as in the previous test, and the nylon one even much more than that. I think it's safe to say that the heat deflection values are confirmed to be at least somewhat correct. Worth mentioning that after the objects were baked and cooled down, all of them snapped pretty easily, even nylon, except for the HT100. I can bend it as much as I want, it just won't snap. The reference PLA Silk downright exploded on my hands. PLA Silk after baking, it's still very stiff, and it snaps and shoots on the other side of the room. Like I mentioned in the beginning, color availability can make or break the filament choice, and in this case it probably will. ESUN PLA-ST is only available in 3 colors, black, grey and white. Elegoo does better with the PLA Pro with its 10 colors, although all of them never seem to be available direct. PETG-HT100 has 7 colors, but get this, Sunlu PLA Plus has 21 base colors and 8 silk colors to top it off. That's 29. Talk about no contest. They even have a much tougher PLA Plus 2.0 with 12 colors for €13 per kilo. The PLA Plus 2.0 promises that it's much tougher, much more impact resistant, much more durable, stronger, and faster to print. The other big factor, or possibly the biggest factor in the purchase decision, is the price. I get that the HT100 is expensive as a specialty filament, but I don't get why the ESUN PLA-ST costs so much more than the cheapest ones. It's got nothing going for it. Sunlu has the upper hand here as well, since you can buy the filaments direct for dirt cheap. You just have to buy 6 rolls at a time. Nylon is of course the most expensive of the bunch. There we go. Now I know when to and when not to use each of these filaments. All PLAs melt very early, and the regular silk is indeed quite brittle, though it is the stiffest. HT100 is very soft, but great with high temperatures. The ESUN PLA-ST is especially good at nothing really, so that gets dropped right away. I'll happily use the HT100 for high temp applications, but Sunlu will remain as my go-to manufacturer for different colors I like to stock. A worthy mention also goes to Geeetech filaments. They have a PLA starting at $10 or €9 direct at their website, and a great choice in colors. Although I didn't find any technical datasheets on their website, so I don't know if they can be trusted at demanding situations. But there are great colors like the marble. Hopefully this video was helpful for you too. Take care. Bye.